listen here. The question number 4 of this exercise 15.1 is like this. The following graph shows the temperature forecast and the actual temperature. The weather forecast, temperature forecast will be given by the weather department. Temperature forecast and the actual temperature of each day of a week. It is given there. Now on which days was the forecast temperature the same as the actual temperature? What was the maximum forecast temperature during the week? What was the minimum actual temperature during the week? So then the last question, on which day the actual temperature differ the most from the forecast temperature? So here you can see forecast temperature is shown in the graph and actual temperature also shown in this graph. So this blue line represents the forecast temperature and green line represents the actual temperature. So along the horizontal line you can take the days here, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Along the vertical line the temperature is taken. It is in degree Celsius. Now on Monday, so 15 degree, that is forecast temperature is 15 degree here. You can see here 15 degree. Then in between 15 and 20, what is the temperature? 17.5. It is the actual temperature. Now on Tuesday, both forecast and actual temperature both are coinciding, that is same 20 degrees Celsius. On Wednesday, this is blue line forecast temperature, it is 25 degrees Celsius. And the same day, it is 30 degrees Celsius and is actual temperature. Okay. So then come to Thursday, the actual temperature is 15 degree but forecast temperature is 22.5 degree. Horizontally you come here and you see it is in between 20 and 25. It is 22.5. And then on Friday you can see both coinciding. Actual temperature and the forecast temperature both are coinciding. It is 15 degree only. So then on Saturday you can see that actual temperature is 25 degrees Celsius but the forecast temperature is 30 degrees Celsius. And the last Sunday, you can see both coinciding at 35 degrees Celsius. Actual and forecast temperature both are coinciding. Now, looking this graph, you answer these questions. First question, let us see the first question now. What is the first question here? On which days was the forecast temperature same as that of actual temperature? Actual.
Tuesday, Friday and Sunday.
You see this table now. On which day they are coinciding? It is, what is that said, Chinmay?
Tuesday, Friday and Sunday. Friday, Sunday.
It is coinciding here in Tuesday and Friday and Sunday.
Friday.
Okay, Tuesday, Friday and Sunday. You can write here the answer here for the first question here. You can write for this first question Tuesday and Friday and Sunday. These are these 3 days. You can see the same temperature. The forecast temperature and the actual temperature both are coinciding. Look at the second question now. What was the maximum forecast temperature during the week? Forecast temperature. And come to this table now. What is the forecast temperature? Blue color line. Where you can see the maximum temperature, the forecast temperature. So here it is blue, 15 degree, 20 degree, 22.5, sorry, 25, 22.5. It is 15. Again it is increased to 30. Then 35 on Sunday. The maximum temperature on the forecast. It is, what is the temperature? 35 degree Celsius. 35 degree Celsius. Okay. So then, third question. What was the minimum actual temperature during the week? Minimum actual temperature. Minimum actual temperature, that is green color line you can say. Minimum, lowest. Here it is 17.5. Green color. 27.5 and it is coming down to 15 degree, again remains same 15 degree and increasing. What is the lowest temperature we can see? 15 degrees Celsius. So the minimum temperature you are seeing here 15 degrees Celsius. You can write answer as 15 degrees Celsius. Then come to the fourth question here. On which day did the actual temperature differ the most from the forecast temperature? The difference is more.
The first day.
You look at this.
The first day.
Here only 2.5. Here same. Here it is 5 degrees Celsius. Here you can see 15 degree and here 22.5. 7.5. Here same. Here only 5 degrees Celsius the same. So here you can see the maximum difference. It is on Thursday. So the answer to this question here on Thursday. So answer to this question here, on which day did the actual temperature differ the most from the forecast temperature? What is the difference you can see here? See here 15 degree, here it is 22.5. 22.5 minus 15, 7.5 degrees Celsius. A difference of 7.5 degrees Celsius. So that much difference you can see in this. So this is the answer to this all the 4 questions. So now after this we will go to the question number 5. Use the tables to draw the linear graphs. You need to draw the linear. Linear means a straight line. You have to join by straight line. The number of days a hillside city received snow in the different years. So it is a, look at this. How many days the snowfall was there? So you can see here 8 days, in 2004 10 days, in 2005 it is 5 days, and 2006 it is 12 days. So now you have to show it in the graph. So now we can draw an horizontal line and also a vertical line. So let me use this. Okay. I'll take this 2 units, 2, 4, 6, 8, 10, 12, 14, 16, 18 like this along the vertical. So it is, let us take days on the vertical line and year on the horizontal line, years. So let me write. So I will write here. The first year, it is 2003 to 2006. So I will write here 2003. So what I will write here, 2003, 2004, 2005, 2006. So I have taken a 2 units gap here. Now, as per the data, you can locate the points on this graph. So on 2003 it was 8 days. 2003 it is 8 days. So I locate this. It is 8 days. Correspondingly, we can locate a point. 2003 vertically go up to 8. So 8 days. Then 2004 it is 10 days. So you can 2004 it is 10 days. You go vertically upward up to 10. So now this is the position. Horizontal. So you can see in the vertical line 10, then horizontally go here up to 2004, then it is a point of intersection here. 2004 it is 10 days. Then 2005 you can see it is 5 days. So it is in between 4 and 6. So 2005 I will come here and represent this point. So this is the point where 2005. So in 2006 you can see it is 12 days. So 2006, from 2006, this is 2006, go up to 12. So here, we can see 12 here, come horizontally up to 2006, then locate the point. Now using a straight line, it's a linear graph, join these points by a straight line now. So now I'm going to join this one using a straight line. This is also another straight line, then like this. So this is the graph for this question, a linear graph now. So by straight lines you join these points. Say in 2003 it was 8 days, in 2004 it was 10 days, in 2005 it is 5 days, and in 2006 it is 12 days. So this is the graph of that question now. Question B here. Population in thousands of men and women in a village in different years. In the year 2003, the number of men 12. So it is number of women 11.3 it is given, but it is in thousand, 11.3 thousand. Into thousand you do that. That means 11,300. So here 2004 it is 12.5, it is 11.9. 2005 13,000, 13,000. Again here 13,200, 13,600, 13,500, 12,800. In thousands it is given. Okay, multiply that one by 1000, then you will get the correct number. So it is decimal means human beings cannot be represented by number of men or women, cannot be a decimal number. Must be a whole number, natural number. So therefore 12 into 1000, 11.3 into 1000, so 11,300, the number of women. So that is all. So now we can draw the vertical line and the horizontal line like this to represent this. So let us this to take year. In this horizontal line you can take the year. So here number of persons. So you can say whether men or women, you can take along the vertical line number of men or women along vertical line. Number of people, okay, number of the population, or otherwise population of men or women. Now both we have to represent in the same graphic. So let us locate at equal distance. Okay, so here is 2003 to 2007. So I will write here 2003, 2004, 2005, 2006, 2007, up to 2007. Here, then the lowest what you can take, see, it is the lowest value is 11,300 up to 12,800. So 11,300 to 12,800. So 11,300. Okay, so now 11,400, 11,500, 11,600, 11,700, 11,800, 11,000. I think it will be, we will need a longer line, so therefore we will do it little bit, we will increase the scale here. So now 11,000, here the lowest value here 11,300. So now if you write here 0, 11,300, then you can take this 11,500, then 11,700, so the 11,900, so then 12,100, so 12,300, so then 12,500, so 12,700, then 12,900, then 13,100, so 13,300, 13,300, then 13,500. So like this with a difference of 200 population. Now in the year, number of men, let us
13,600 is also there, sir.
13,600 is also there. Okay, so it is, you can increase one more. So 13,000 it is 700. So in between it will come. So now you can mention like this, you can use the different colors here. If I use the red color line, it is represents the number of men. Okay, so then if I use another color, I will use blue color here, it represents the number of women. Okay, so now number of men, 12 in the year 2000, in the year 2003 it is 12,000. So 2003 up to 12,000 you can go, 12,000 between, it will be in between here. This is the position. 11,900 and 12,100. Then in 2004, 12,500. In 2004, 12,500. You can mark mark the points like this. So this is the point. Horizontally to 12,500. Then in 5 it is 13,000. In 2005 it is 13,000. So it is in between this 13,100 and 12,900 here. So it is horizontally, it is in between these two. Then in the year 2006 it is 13,200. 13,200 exactly will be in between these two. So it will come up to here. Okay. Then the last one 2007 it is 13,500. So 13,500 you can see here. Okay. Now you can join this one using scale. Draw straight lines here like this. It is increasing. Okay. Then another one, number of women. In the year 2003, 11,300. You can change the color now. So 11,300. So it is 2003. It is here. So then in the year 2004, it is 11,900. 2004 it is 11,900. So in the year 2005. Okay, sir. Now 2004 over 2005 you can see it is 13. It is coinciding here 13,000. 2005 it is same point. So the number of men and women become same. So then in 2006 it is increased 13,600. 2006 you can see here 13,600. It is in between these two. So you can write here this point. This is the point. So then again it came down. In 2007 it is 12,800. 12,800 means it is in between 12,700 and 900 horizontally. Come here. This is the position. So like this. Then you join this one using scale with a different color. Then it increasing like this. Then it came down again. So this is the graph you are getting, and this represents the women. This one actually women, and this is men graph. Graph of men, number of men, population of men, and the population of women. Okay, so this is the graph of this one. See, horizontally you are taking the number years, and vertically you are taking the population. Population you can take. Instead of writing this one, you can write population. So one line represents the men, other one represents the women. Red color representing men. It is gradually increasing, but here this is sudden increasing. The increase is there, just crossing the number of men, but again it came down. So this analysis you can make using this graph. Watch this question number 6 now. A courier person cycles from a town to a neighboring suburban area to deliver a parcel to a merchant. His distance from the town at different times is as shown by the following graph. So now look at this is the graph. So 9 a.m., 10 a.m., 11 a.m. and 12 a.m. At 9 a.m., so they start from 8, 9, 10, 11, 12. And here distance in kilometer 2, 4, 6, 8, 10, 12. It is given in kilometers. Now 9 a.m. it is at 10 kilometers. 10 a.m. it is at 16 kilometers. Then it is, you see, in between 10 a.m. and 10:30, exactly half. At 10:30 again it is at 16 kilometer only. Okay, so 10 a.m. to 10:30, 16 kilometer. At 10 a.m. also 16 kilometer, 10:30 also 16 kilometer only. Then 11 a.m. is somewhere at 20 kilometer. So it is 12 noon, and between 12 and 11 it is 11:30. It is at 11:30 it is 22 kilometer. So like this you can find out the distance covered at any point of time here between 8 to 12. Now first question you see here. What is the scale taken for the time axis? What is the scale taken for the time axis? Time axis you see, it is for 1 hour you have taken 1, 2, 3, 4 units. So your answer here, first question, so 1 unit, see sir, 4 units is equal to 1 hour. So this is the scale you have taken, first question. What is the scale factor you have taken here? 1 hour, this difference. 1, 2, 3, 4 units are there. For another 1 hour, 1, 2, 3, 4. Everywhere you can see 4 units are taken to represent 1 hour. That is the scale you have taken. This is the scale you have taken here. Scale for time axis. Time axis it is horizontal line. Then come to the second question. How much time did the person take for the travel? How much time he has taken to travel? Okay, so from here 9 a.m. he was at a 10 kilometer distance. Okay, at 8 a.m. he was at 0 distance. From here to here he is taken say 10 at a 10 kilometer 9 a.m. Then from 8 a.m. to here up to 11:30. What is the time taken? You tell me. What is the time taken? Total time taken? This is 11:30. 1 hour, 2 hour, 2:30. If you include this, 3:30. It is at a 0 distance where he is starting. At 9 a.m. he is at exactly 10 kilometer distance. And at 10 a.m. it is at 16 kilometer distance. So 10:30 also 16 kilometer. So then at 11:30 it is 22 kilometers. Now you have to find out the total time taken to travel up to here. Up to 22 kilometers. Up to 22 kilometers. Second question, it is 3.5 hours. That is from, you can write 8 a.m. to 11:30 a.m. If you start from 8 a.m., because it is mentioned here 8 a.m. at 0 distance, 0 kilometer. So 8 a.m. to 9 a.m. is traveled up to 10 kilometers. Then from 9 a.m. to 10 a.m. he traveled 16 up to 16 kilometers. 10:30 he was there only. So 11 he traveled some distance around 20 kilometers. Then 11:30 he is at 22 kilometers. So that is the distance covered, and the time 8 a.m. to 11:30. So 8 a.m. to 11:30 it is 3.5 hours. Then let us go to the third question now. Look at this. Third question. How far is the place of the merchant from the town? From the town. How far is the place of the merchant from the town? So let us take this is the town. From here to travel here, how much distance we cover? 22 kilometers. You can write here 22 kilometers. Answer here 22 kilometers. So the merchant is at 22 kilometers from the town. Okay. Then the next question. Question number D. Did the person stop on his way? Did the person stop anywhere on his way? Yes, he stopped here. Look at this. At 10 a.m. he stopped, and up to 10:30 he was at the same distance. So, fourth question. So, yes, he stopped at 10 a.m. From 10 a.m. to 10:30 a.m. Because you can see graph is parallel to horizontal line at see graph is parallel so that is at the same distance. So you can see that at 10 a.m. also it is at 16. What is it? At what kilometer? At 10 a.m. it is at 16 kilometer. At 16 kilometer distance, and at 10:30 a.m. also at 16 kilometer distance. Both the time is at the 16 kilometer distance only. Therefore, he has given a stop at 10 a.m. to 10:30 a.m. So the next question here. During which period did he ride fastest? So you have to find out. You can see here from 8 a.m. to 10 a.m. 8 a.m. to 9 a.m. he has traveled 10 kilometers. So you can see 8 to 9 he has traveled 10 kilometers. Then 9 to 10 you can see 9 to 10, 10 to 16, that is only 6 kilometer. So 9 to 10, 10 to 16, only 6 kilometer. 10 to 11 you can see here, I think it is 19 kilometers. 10 here 16 to 19, so only 3 kilometers. So 10 to 11, only 3 kilometers. So again from 11 to 12 you can see, so 11, it is 19, 12, I think we stopped, very less only. Here maximum distance we covered is 8 to 9. So question number 5, from 8 a.m. to 9 a.m. he covered around 10 kilometer distance. Morning he traveled maximum distance of 10 kilometer. The last question of this exercise, can there be a time temperature graph as follows? Justify your answer. Time and temperature graph. The time is increasing, whether the temperature is increasing or decreasing or remains same, that you have to mention here. Now look at this graph, you observe this graph. Suppose here time, maybe 0, 10, 0, 1, 2, 3, 4 like that, time is increasing here. Then temperature also increasing. As the time, you see, if you come to this time, you can see the temperature is here. Okay, you come here, this is the time. If I take this is 8 a.m., 9 a.m., 10 a.m. So 10 a.m. temperature here, 20 degree, 22 degree like that, means it is increasing only. You can see everywhere, the temperature also increasing. As the time increasing, temperature also increasing. So this is possible. So it is possible. When the time increases, the temperature may increase. Morning time, early morning it will be less hot, till the noon it will be increasing only. Temperature will be increasing. This graph is possible. As the time increases, here temperature, see around maybe around 12 noon, the temperature may be maximum here. Then around 1 p.m. it may be decreasing. Okay, temperature here, temperature time low. Then again you see this, it is decreasing. As the time increases, the temperature is decreasing. At 12 noon it is maximum. As the time increases, it is coming down, you see, graph is coming down. So as the time increases, temperature is decreasing. It is possible. So noon to evening you can see. Noon it will be maximum at noon, around 12 o'clock in the noon, afternoon, maybe in the noon. So then afternoon it decreases, keep on decreases till the evening. So then it is possible. So this is also possible. This graph is also possible. Okay. Come to this table now. So this maybe you take 8 a.m. 8 a.m. temperature here 25 degree, 26 degree, 27 degree, 28 degree, like that it goes means 8 a.m. you can see all the temperature. Is it possible? It is going to infinity.
No, sir.
Is it possible? So this is not possible. This is not possible. At 8 a.m. it cannot be like this. Graph cannot go like this. At 8 a.m. you can see, you can take this point, anywhere. It is going to infinity. At 8 a.m. temperature goes to infinity means it is impossible. This is not possible. This graph is not possible. Now come to this one. As the time increases, temperature remains same. Temperature is same as the time increases. So you can increase the time 8 to 9, 10. Maybe certain times the hardness may remain same. Or 8 to 9, 8 a.m. then 8:10, 8:20, 8:30, up to 9 o'clock it may remain same. This graph is also possible. This is also possible. But this graph, third graph is not possible. At 8 a.m. you cannot get the infinite temperature. So this graph is not possible. Except the third one, all the graphs are possible. So that's the end of this exercise questions.